Hello viewers, welcome back to the channel. This is day 5 of our Arduino series. In today's video, we are going to learn one of the most important and basic concepts in Arduino programming, digital pins, and especially what high and low means. If you truly want to understand Arduino, electronics or even robotics, then this concept is non-negotiable. Almost every Arduino projects depend on this idea. So, I strongly recommend you to watch this video patiently till the end because today's topic will build a strong foundation for everything coming next. First, let's understand what are digital pins. On an Arduino board, you can see many pins. Some of these pins are called digital pins. Digital pins can work in only two states, high or low, that represents on or off. For easy understanding, let's use a real life example. Think of a wall switch in your house. When the switch is on, the light glows. When the switch is off, the light turns off. Arduino digital pins work in the same way. High is like the switch on, low is like the switch off. So, Arduino controls the electronic components by switching the pins between high and low. Next, what does high mean? When a digital pin on an Arduino is set to high, the pin is placed in an active state and outputs a logical high signal. On most Arduino boards, high state corresponds to the pin supplying the voltage, typically 5 volt or 3.3 volts on boards that operate at lower logic levels. This voltage allows current to flow through a connected external components, enabling devices such as LEDs, relays or motor drivers to operate. Therefore, setting a digital pin to high instructs the Arduino to provide voltage at that pin, allowing connected hardware to function as intended. In digital electronics, high represents the logic value 1 indicating on or true condition. What happens electrically? When you write digital write of 8, high, it indicates the Arduino connects the pin 8 internally to its positive supply voltage, makes that voltage available at the pin, allows the current to flow from the pin through the component to ground. This is how LEDs light up, relays energize, and motors start turning. What does low means? When a digital pin on an Arduino is set to low, the pin is placed in an inactive state and in simply we can say the Arduino is not supplying voltage on that pin. Electrically, a low state corresponds to the pin supplying zero voltage and the pin is connected internally to the ground. What happens electrically? When you write digital write of 8, low, the Arduino connects the pin 8 to the ground, pulls the voltage level down to 0, stops current flow from the pin. This effectively turns off most connected devices. Low is not nothing, which means a very common misunderstanding among the beginners. It is the idea that low means nothing is happening. This is not true. In digital electronics, low is an active and intentional state, just like high. Low is not an empty, passive or ignored state in digital electronics. When a pin is set to low, the microcontroller actively connects that pin to the ground, holding it firmly at 0 volt. This intentional grounding plays a crucial role in stabilizing signals as it removes any leftover charges, prevents the pin from floating. By doing so, low reduces the susceptibility to electrical noise and eliminates random or unpredictable readings. As a result, the circuit behaves in a consistent and reliable way. ensuring that the Arduino and connected components respond exactly as intended. So far, we have talked about output mode. When a digital pin on an Arduino is configured as an input, the board does not send out the voltage. Instead, it listens for an external signal. In this mode, a reading of high means that a sufficient voltage level is detected, indicating a logic value of 1, while low means no voltage or ground level is detected, representing a logic value of 0. For example, when using the statement int button state is equal to digital read of 2, the Arduino checks the voltage present on a digital pin 2. If a button connected to the pin is pressed, it typically connects the pin to the voltage source, causing the Arduino to read high. When the button is released, the pin is no longer connected to the voltage and is pulled to ground, so the Arduino reads low. This mechanism allows the Arduino to detect user action such as button presses and respond accordingly in a program. If you found this video is useful, don't forget to like and share. For more beginner-friendly electronics and Arduino tutorials, please subscribe to the channel. Thanks for watching and I will see you in the next video.